Hi everybody. I wanted to come back and finish the last 4 problems that I didn't get to in class. These are on page 61, I believe, of your workbook. It's problem number 21. We did get up through 20 in class, and these are not recorded, but the workbook will be posted. I am recording this video with my iPad, not in Zoom. It's the Zoom recordings that give me trouble. So hopefully this one will be pretty clear and easy to follow. But I want to solve, and I am going to check these. We didn't in class because I was trying to save time. But now that time is not really an option or a problem, I'm going to go ahead and check them for you in case you did that as part of your homework. So number 21, this one has parentheses. And of course we need to deal with those first. So let's distribute the -7 to both terms here. So I have a -7v, and this question, a very good question, came up in class. So let me highlight those two just so you're sure of what you're multiplying there. -7 times -9 is positive 63. And then of course your 84 and your greater than equal to sign come down. So let's solve this inequality. I can already tell you that we have a closed interval, but we still need to know which direction that arrow is going to go, and we have to solve to know that. So here's the variable side, and here's the constant side. So this inequality is not in standard form. The variable's on the right. So let's do a -63 and -63 and cancel. So I'm left with a 21 positive is greater than equal to -7v. So then I will divide by the -7. And this is important. If you are dividing by a negative, remember what that does for us. That is going to reverse the sign right there. So I am left with, let's cancel those -7s. I'm left with a v and a -3. And this is not standardized, so let's go ahead and standardize it. Remember, in a solution you have to move everything. So you want, if you study this out here, let me zoom in, you see that that large part of the arrow is with the V. That needs to be the case here as well. Okay. Another good question came up in class. Is it okay to reverse these signs this many times in one problem? And it is. That's fine. This looks like I'm turning it back to the original direction, and I am, but what I'm also doing is reversing these. So as long as in the solution you're reversing all of them, you're okay. You just have to do all 3 pieces of that solution. Okay, so let's graph this one. I have a -3 as my starting point, and it is a closed interval. So -3 could be one of the solutions. Sorry, didn't mean to zoom in. So here's the closed. And in standard form, right here, this is telling me to shade to the right. That's why I wanted to standardize, because that shows me the direction in which I need to shade. So to check this one, I'm going to take a -2. That would be here at this space. You could use a 0. You could use any positive number that would be in that yellow range. But let's plug in a -2 and see what we get. So I go back to my original and I have 84 is greater than equal to negative 7 times v minus 9. And I'm going to let v be negative 2. Let's see if that will work here. So 84 greater than equal to negative 7, and instead of v I'm going to use negative 2 because that's what I'm trying to test. Parenthesis first, negative 2 minus 9, that's a negative 11, times a negative 7, and that's going to be a positive 77. And this is saying that 84 is greater than or equal to positive 77. That's a true statement. So that tells me that my math on number 21 is okay. And again, I know in class we did not do this green step today because of time, but on this page I will do that. Now, if you use something other than negative 2, your solution may not be the same as mine. It wouldn't be, but it still should be true if you're in the yellow zone. So you don't have to use a negative 2, but if you did, it would check out. Okay, number 22 is another one of those really tough ones. This one is not an easy problem. But if you were in the class today, we saw several of these, so hopefully they're getting a little easier. The first thing I'm going to do is to put a 1 in front of my r. This one has no parentheses, so it is definitely solvable right here. And the variable side is the left, so this is in standard form. And the constant is over here. And we talked about in class that we need to get rid of that 2 on the bottom. I want to eliminate this double-decker part of the problem. So I'm going to do that by using reciprocals. And I'm going to bring my 2 up to the top. And then that 1 that I put in with my r, the coefficient, that's going to be the bottom. So here's how that canceling shapes up. This 1 and that 1 that I used right there cancel each other. So I just put it in there for a minute. And then these 2's cancel each other, which is really what all of that was about. So all of this, the 1's are going to cancel, the 2's are going to cancel. All of that's going away. So what I want left is a negative 8 plus that r. And that is greater than negative 8 times 2 over 1 is negative 16. And then I will add 8 to both sides. We talked about every time we cancel, we need to rewrite. R is greater than negative 8. And this is already in standard form. So in my graph, I have an open interval starting at negative 8. It's an open interval, so you don't color the circle. You shade to the right, greater than negative 8. So the solution to this one has to be more than negative 8. Negative 8 is not an option. It could be negative 7. It could be negative 1. It could be 0. It could be anything up the number line that I can't see. And this time, I'm going to use the negative 7 as my test solution. I like to go with that first possible one, but you don't have to. You could pick any of them. You do, however, need your original problem. So you have a negative 8 plus r divided by 2. and that is supposed to be greater than negative 8. So let's test this out using negative 7 for that r. So I have negative 8 plus negative 7, and I like parentheses because I have a plus and a minus sign back to back, over 2, and that's all supposed to be greater than a negative 8. So the top comes up to be negative 15 over 2 is greater than negative 8. Well, negative 15 divided by 2 is negative 7.5, and that is greater than negative 8. Negative 7.5 is closer to 0 than negative 8. So that is a true solution. Again, this is the checking part. Okay, let's look at, I don't think the HiSET or any test will ask you to check. If you're able to solve and graph, you're in good shape. All right, the number 23 has no parentheses. So let's go ahead and put in our solving frame. And I'm also going to put a 1 with that x because we'll need him in just a minute. So this is my variable side. This is my constant side. So this one is in standard form. Plus 8, plus 8. Cancel. Remember, every time you cancel, you need to copy. So I have a 1 over a negative 6 and an x, and then a negative 4 on this side. So we need to get rid of the 1/6, or not get rid of it, we need to move it over to the constant side, and we do that with a reciprocal. And as soon as I write that negative in that parentheses, I am multiplying by a negative. As soon as I put that sign in there, I have to reverse my arrow. So as soon as that negative goes in there, come down here and make the reversal on the arrow. So negative 6 over 1 and negative 6 over 1. Here's the canceling. So I am left with x, and on this side is positive 24. This is in standard form. It is ready to graph. This is a closed interval starting at positive 24. So 24, make the circle and close it. It's a closed interval. So 24 is a solution here. You can use that in your solution set. And we're going to shade to the right of that one. And I'm going to pick 25 as my test solution. You could use 24. It's going to be one of them. But let's see what we get when we use a 25. So I have, here's the original, x over negative 6 minus 8 is less than or equal to negative 12. So 25 goes in for x divided by negative 6 minus 8 is less than or equal to negative 12. So all I did is plug in the 25 as my test solution. Then I'm going to encourage you to put this in your calculator. Don't even try to do it in steps. Do 25 ABC negative 6 subtract 8. And I'm going to do the same thing if I can get my calculator to come on. So 25 ABC 6 negative minus or subtract 8 equals, and I got negative 12 and 1/6. Negative 12 and 1/6 is less than negative 12, and that's true. Negative 12 and 1/6 is deeper in the hole. It's further from 0 than the other side. So this is a true statement. And that tells me that my math is correct. This checking step helps me to see that my solution is correct. Okay, last one here. We have m minus 3 over 2 is less than or equal to 5. So let's go ahead and make the solving frame. Variable, constant. And let's put a 1 in front of that m. And I'm going to move that 24 out of the way. Put him up here. Okay, I need to get rid of that 2 on the bottom. That's the thing that looks so bad. And to do that, I'm going to use the 1 that I inserted and that 2. We're going to get a reciprocal of 1/2. So make your pockets deep. That's multiplying. Multiplying. But this is positive 2 over 1, so we don't have to worry about a reversal. We're multiplying by a positive. Here comes the canceling. The 1's cancel and the 2's cancel. So I am left with m minus 3. We multiplied by a positive, so we don't flip that arrow. And then 5 times 2 over 1 is 10. Then I'm going to add 3 and cancel. So m is less than or equal to a positive 13. And this is in standard form. So I come over to my graph and I make a place for my positive 13. Draw a circle and close it. This is a closed interval. 13 is a solution, as is everything less than 13. And to check this one, I like to go first number into that interval would be a 12, first whole number. So let's test this 12 and see if this proves to be true. So I have m minus 3 over 2 is less than or equal to 5. And I'm going to put the 12 in there to test it. So 12 minus 3 over 2 is less than or equal to 5. 12 minus 3 is 9 over 2. Couple of ways you can do this, and let me just go ahead since I'm recording and show you both. If you use the ABC key, if you do this as a fraction, you're going to get 9/2. So 9 ABC2 is 4.5, and that's less than 5. That's a true statement. If you want to do it with the division key, so do 9 divided by 2, you'll get 4.5, which is still less than 1/2. So either way you do it, it's true. But the point here that I wanted to show you is if you need a fraction answer, use the fraction key. If you need a decimal answer, use the division key. And that will give you whichever form you're looking for. So if your answer choices on the test are all in decimal form, then I would do this as a decimal problem. And if they're all fractions, work it as a fraction problem. Okay, those are all true. Everything looks fine. Homework for Monday comes from those HiSET problems in the back. These are not easy problems. So we will look at these on Monday. I'll work them with you. And then if you want to go ahead and look at the final review for this chapter, it's on the next page. You can also take a look at that. If you don't, we'll look at that together. But those are coming up, and then we have word problems, and we'll be done with this course. It's been a very long course. Okay, I'll see you for class Monday at 3:15. Email me if you need me. But there are those last 4 problems. Have a good weekend. Bye-bye.